Hello everyone, let's talk about logistic regression. Logistics regression is used to classify the data. For example, to classify whether email is spam or not, I have provided few references below in the description regarding logistic regression. How let's see about this algorithm. The important thing you to understand about sigmoid function.
A sigmoid function is a mathematical function having a characteristic S-shaped curve or sigmoid curve. In general, a sigmoid function is monotonic, and has a first derivative which is bell-shaped. Conversely, the integral of any continuous, non-negative.
In a statistical classification problem with two classes, a decision boundary or decision surface is a hypersurface that partitions the underlying vector space into two sets, one for each class. The classifier will classify all the points on one side of. Cost functions are used to estimate how badly models are performing. Put simply, a cost function is a measure of how wrong a model is in terms of its ability to estimate the relationship between x and y. This is typically expressed as a difference or d. First, initialize the model. Second, for each record of the data set, calculate the sigmoid activation function and calculate the cost. Improve the model to ensure that the cost is reducing.
Hello everyone. Now let us look into the actual example of logistic regression. In logistic regression, here you can see the libraries have been imported, and here you can see the data here. So this is how the data will looks. Now when you run the describe function, you can see the mean standard of individual columns. Now I already explained you in the previous video why we need a mean and standards. This is very important points to make a note. Now when you run this info function, you can see the distribution of data. Now you can see what are the columns data having how many non-null values. So for this particular column, so there are 145 non-null values. It means the 5 are null values. So in this case, what we'll do is we will remove those null value columns in the related rows for the respective columns. So then if you see info, you can see 145 for all the columns. It means the null values which is there in the petals, we have removed it. Once we remove it, then we will run this pair plot. So pair plot will do simple correlation, and we can see the data distribution over the classes with respect to the two dimensions. Now if you see this particular graph, you see this is y-axis is the sepal length and x-axis is the sepal width. But you can see we cannot able to make how the classes are distributed with respect to these two dimensions. Now you can see we are counting the number of values in the classes. Now we can see there are 4 classes. Now this vertical, these two are same. So what we can do is we can club these two data, and we have setosa, and this we have different setosa, but these two are same. So we can club these two classes. Once we club those two groups, then finally we come up with this classes. So this particular class has 50 rows, and this particular class has 50 rows, and this particular class has 50 rows. Now what we are doing is we are simply filtering out this class so that we will do binary classification. So there is another set of things to do in multiple classification, but now here to give a idea about the logistic regression, now we are picking up only 2 classes. So when we pick up only two classes and we do pair plot, which is correlation kind of a diagram, a kind of a algorithm. So what we do is we will get the how the class is distributed between the two dimensions. Now this is for sepal length and sepal width, and you can see that this is sepal length and petal length. So like that, now you can see a little bit clear distribution of classes with respect to the two dimension. But still you see certain data has been overlapped in this class. So blue curve is overlapped in this orange class. The blue curve is overlapped in this orange class. So there is a little bit data deviation is there within its own classes. So when you look into this particular column vector, you can see the data distribution is not continuous. So there is a large gap between the data distribution. So what we'll do is we'll filter out this data which is less than 1, and we'll see the distribution. Once we filter out this data, you can see that the distribution is continuous. When the distribution is continuous, it is easy to, we'll get to very good model. So now again, when we do the pair plot, you can see there is a clean classifications of the data between any two dimensions. Now let us look at the data. So this is the data here. Now here we are using standard scaler. Now I already explained you there is something about mileage, and there is something we talk about number of liters per kilometers. So it's to have a better standardization. So it's instead of saying that 1000 milliliters is given 1000 centimeters mileage, it will not look nice. It's not making any sense. So in order to convert a given data set within a column vector between 0 to 1, we use standard scaler. So when you do have a standard scaler, what we'll do is takes the maximum value and minimum value and do the normalization, so that the value of every element in the column is between the value 0 and 1 with respect to maximum and minimum. Now here it's, and this will be helping us for modeling. Now here these are the steps that we have to follow. First we have to do weight initialization. So weight initialization is a very important step. So this is very highly regarded in neural networks, but for now for logistic regression we can go with weights and bias as zeros and 0. Weight is for slope and bias is for the intercept. Now we do sigmoid classification activation. So sigmoid activation is a sigmoid function where you take a given value and you calculate it. You will get a value between 0 to 1. So if that value is below the 0.5, then you consider that this class is 0. If it is more than 0.5, then you consider the class as 1. So these are the same classes that you can see here. Now what we did is we have removed this class names and converted them in one of the classes 1 and another class as 0. Now here what we are doing is we are doing model optimization. So in model optimization, what we are doing with the existing model, that is nothing but weights and bias, we are trying to calculate the result. Now after the result, what we are doing is we are calculating the cost given this cost entropy kind of a formula. Now here what we are doing is we are calculating the gradients. So gradients are derived from the derivative of the functions, so which will give you a step that you can increment or increment to further improve the models. And we'll mark it as we'll store it as a grad and we'll send it to the model prediction. So in model predict, what we do is for given number of iterations, it will keep on calling this function, so that gradually the model will improve, and then we get the values of cost that we'll see in the upcoming videos. Now here once you get the final model, we'll take the input, and from input what we'll do is we'll get the predicted values. So here what I said is if it's greater than 0.5, then the class is 1, otherwise if it's less than 0.5, it is class is 0. So we make predictions. Now this is the actual implementation here. So in the actual implementation, we take the features, we initialize the weights, that is bias, and weight slope, and then we do predictions, and finally we get a model. Model is that's W and weights and bias, or you can say slope or intercept. And now here we are training the input train, and then we get the final train values, and then we get final testing values. So here what we're trying to do is this is our just by looking into the sigmoid activation function. Now what we're doing here, we start getting these values by predict. So what we do is whatever this predicted model is there, that we'll get it, and then we will get the output values from the algorithm. So we'll do prediction out of the model, and then we start checking the accuracy. So whatever trained is there, actual values, we'll check with the predicted values for training, and the same we'll do for testing, and we see the accuracy is 1 means for 100%. And this training and testing accuracy are same because we pull the data out of the from same data set. Otherwise training accuracy will be more than the testing accuracy. Now you can see the given plots. So given number of iterations in hundreds, you can see the cost is reducing. It means the model is improving when the cost is keep on reducing. So instead of implementing the above functions, what we can do is we can directly implement logistic regression, and then we can fit calling this fit function to find out the model, and then you can see the intercept is nothing but the bias, and here coefficient nothing but weights are slope. Now here what we do is we'll make a prediction and we find out the score, and you can see the accuracy is 100%. So this is all about logistic regression. Thank you very much for listening.